All right, guys, part 2 in the basic trig review. So you should be very familiar with trig. This is algebra 2, taught you in geometry. Let's hit it. So we've got an angle, we got some sides, we got a missing side. We're trying to find the length of this missing side here. Remember, if you have a right triangle, first thing you should pop in your head, Pythagorean theorem. Second thing, trig. Check for that, see what you can do. I've only got one side known, so I can't use Pythagorean theorem to solve it. It is a right triangle, so I can use my basic trig ratios to solve this thing. So I know this is the reference angle. I'm looking for the opposite, and I have the hypotenuse. That means I'm going with sine here. Write out your setup. Sine of 64 is equal to opposite over hypotenuse. That's just a basic trig equation. Multiply both sides by 25, or this is just a number. Sine of 64, you can type that in the calculator. Sine of 64. Some random decimal that no one really cares about. So let's see what it is. Maybe. I think that. Who cares? How do I solve it? Multiply both sides by my denominator here, 25. Now in geometry, I'll let you go ahead and use that decimal to 4 decimal places. Here, let's just, why bother? Just type it in. 25 times sine of 64. 25 times sine of 64. And you get some other random decimal number. It says round to the nearest tenth, so whenever it finally spits out a number, 22.5 it is. No units, so don't worry about it. 22.5, whatever kind of units we're dealing with here. Let's look at this next one. My reference angle, again, I don't have enough information for Pythagorean theorem, but I do have a right triangle. So I'm using one of my basic trig ratios. Opposite, adjacent, that's giving me a tangent. Tangent of 47 is x over 12. And again, we don't really care what tangent of 47 is, just do the basic algebra. It's just some sort of number. It's like logs are some sort of number. Multiply. 12. Make sure you hit the multiplication button though. Tangent of 47. And we get something, 12.9 for round of the tenths. 12.9 equals x. Nice easy peasy stuff here. Reference angle. Again, I don't have enough information for Pythagorean theorem. I know my hypotenuse. I'm looking for my adjacent this time. Who we've ever guessed. We're going cosine of 18. And it is adjacent over hypotenuse, so x over 34. Guess what to do. Hopefully you guessed it right. 34 times cosine of 18. This is not new, people. Now, before I did let you round intermediately, you really don't need to, though. You should be able to manipulate these expressions with cosine, log, whatever kind of function you're dealing with. 32.3 it is. Oh, that was not a good curve, was it? There we go, 32.3 whatevers. All right, one more. We got the opposite. We're looking for the adjacent. That's telling me to use tangent of 35 is equal to 9 over x. 2 steps on this one, okay? What's my denominator? X. So freaking multiply by it. I've got x times tangent 35. Okay, how do I get x by itself? Divide by 35, or tangent 35. X equals 9 over tangent 35. Type it in. And, oh, yeah, I need to close my parentheses. 4.9. Cool. Hey, look, it's the same as the one above. Coincidence? Yeah, it's definitely coincidence. So that's all. If your x is on the bottom, just multiply both sides by x and then divide by whatever that thing is. It's just some number, people. Don't let it throw you off because it's got letters in it. It's still just a number. All right, a couple more. Opposite, hypotenuse. That's an O, by the way. So that's going to be a sine 63 equals 27 over x. So x, you can go ahead and figure that out. It's going to just swap places, right? 27 over sine of 63. Super basic algebra there. It's just with words instead of just letters and numbers. Still just algebra. And yes, make sure you put the dang parentheses in there because it's very picky apparently. There we go, 30.3. Good habit anyway to put closure parentheses. Let's see, that's 30. Oh, hey, that's 30. I'm not going to do any work at all because this is my short leg. This is 18. Okay, maybe I will do work. I'm going to do it both ways. So you should be able to recognize this is your special right triangle. And to get this one, I divide 18 by square root of 3. This is 6 square roots of 3, making this 12 square roots of 3. Now, if you didn't recognize it as your special right triangle, or if you don't have them memorized, feel free to do the trig. This is adjacent and hypotenuse. Use cosine. Cosine 30 is adjacent over hypotenuse. Those are going to switch positions. We multiply both sides by x and we divide both sides by cosine 30. That's how this happened. That's going to give us a decimal. Actually, it'll give us 12 square roots of 3. Leave it exact. Wait, what did our directions say? Round to the nearest tenth, so listen to your directions. 20.8. But you see, we got the same thing whether we use trig or if we memorize our special right triangle. It's a little less work here. Just divide and multiply. Here you actually have to set up an equation and solve. Whatever you want to do, it's on you. Now, what if we need to know an angle? Remember, that's whenever you use your inverse trig functions. Theta would be sine inverse of x. Theta is cosine inverse of x. So all an inverse function does is undo it. Remember, if you have a function that's inverse and you compose them, you plug them into each other, you get x out, right? So if I plug in cosine inverse, I'll do it on this one. If I do tangent inverse of both sides of my equation, because they are inverses, you should know what happens. What happens? The inverse of the original function produces x, your argument out. In this case, that's theta. And that's exactly why we do that, to get our angles. Couldn't explain it that way last year because, well, you didn't know what inverses were, but now you do. Just realize that if you take an inverse of its original function, you get whatever your argument is out. Oh, hey, look, we can do Pythagorean theorem, find the side, right? Who cares? We're not looking for the side, we're looking for the angle. Opposite, adjacent, better be using tangent. tangent of what? Theta is my angle equals 8 over 14. Theta, all I have to do is tangent inverse on the other side of my equation, 8/14. Take a calculator, get an inverse. Here's my angle. I got my adjacent and my hypotenuse. That's going to be a cosine. And if you want to, you can go ahead and just say theta equals, because these are just one-step equations, basically. Cosine would be adjacent over hypotenuse, 38 over 40. Last year, I needed to write up this step, the setup step here. I'm okay if you just give me the angle, as long as you write down what you're doing to get the angle. That's sufficient for me. And we get 18.2. Right? What's next? Some more practice and then some word problems. All right, not too shabby. Opposite hypotenuse, sine inverse of 17 over 22. That's what theta is. And hang on, my phone is buzzing. So, 1 second. Sorry about that. I'm back. And yeah, so let's go over here. Okay. So sine inverse, 17 over 22, 50.6 degrees. Over here, opposite, don't know, adjacent, hypotenuse, gotcha, cosine. We're doing inverse of 11 over 48. Now, that's what theta is. And we get 76.8 degrees. All right, guys, you should be very fluent with these. Those are basic trig problems. Here we got words, but, oh, let me this back. Here we got words, but yeah, shouldn't be any different. All right, let's first remind ourselves about angles of elevation and depression. So you might remember me bashing my head on the electrical outlets. Yeah, that was whenever I was talking about angles of elevation, depression. If you don't, that's okay. So first, to talk about an angle of elevation or depression, you must be referencing a horizontal. So we got ourselves a right triangle somewhere. Sure. Now, if I'm talking about the angle of elevation, that's down here looking up. That's the angle of elevation. If I'm talking about the angle of depression, that's the angle looking down from the horizontal. This angle right here. We always have to start at a horizontal. So that is our angle of depression. Now these are both horizontal lines, so that means they're both parallel, right? So how is this angle related to that angle? alternate interior angles. And we know those things are congruent whenever we're dealing with parallel lines. So, long story short, angle of elevation is always going to be equal to the angle of depression. So if you're confused at how to draw a triangle, draw it like this and stick the angle right there if it's depression or elevation, you'll be fine. Okay. So here we got angle of elevation problems. There's a diagram, blah, blah, blah. Sketch it. Angle of elevation, draw like this. No question. There's my angle. There's the thing. That's a 90. Okay. Oh, it tells me this is 5 degrees. Maybe you want to read the problem before you start, putting stuff. That's 5 degrees. Angle of elevation from that is 5 degrees. If the lighthouse is 161 feet above sea level, so you have to use common sense. Above sea level, that's this part, not this part or that part. How far is the boat from the lighthouse? Okay, well that's got to be this part. Okay, solve it. Opposite, adjacent. That's gonna be a tangent. 5 degrees is equal to 161 over x. So we'll go to the tens place. Let's see what we get. So I'm going to multiply both sides by x and then divide by tangent of 5. That's just going to do this. And we get 1,840.2 feet. Okay, so now we actually are having context here, feet. Go ahead, include the units. Bad habit not to include the units. Check something real quick like. On the next one, the angle of elevation for a slide. Bottom slide to the top of the slide is 44 degrees. All right, so we're going to figure out what does that mean. Let's sketch it. Okay, we got an angle of elevation. Here's the top of the slide. Here's the bottom of the slide. It's 16 feet above the ground. Let's find the length of the slide. So that's 44. This is a right angle. So with these, you're going to have to make the assumptions that the ground is flat and level, that things that should be standing straight up are, oh, yeah. So then it's a straight slide, so it's not one of those little curvy things. Yeah, that wouldn't be good. But yeah, look for this again. So that's boring. It's the exact same problem we just did with different numbers. Tangent of 44 equals 16 over x. Will x always be on the bottom? No. We always use tangent? No. You got to read the problem, people. Hey. So x would be 16 over tangent of 44. And we get 16.6. Again, that is feet. Excuse me. Back once again. Okay, so this one sounds a little more interesting. 10-foot ramp is used to unload furniture from a truck. So think about it. Is this the ramp? No. Is this the ramp? No. This is the ramp. Okay. So this is 10 feet. The truck sits 3 feet above the ground. That's 3 feet. And it says find the measure of the angle that the ramp makes to the ground. Ramp, ground, angle. So that's opposite and hypotenuse. That's going to be a sine inverse. Looking for an angle. Whenever you're looking for an angle, you're going to use an inverse trig function. That is whatever the heck it is. 17.5 degrees. rounding. So some of you might be saying, oh, it's 17.4. Yes, I know your rounding sucks, but that's how you round people. This is a 4. The next number is 5 or bigger. It goes up. This was not 5 or bigger. It would stay. Done. Yes, I know you said rounding. It's okay. Angle of depression. So again, if you want to, you can always just set it up like this and make sense of the problem, but I'm going to draw them how the scenario should be. The dude's sitting on top, see, he's sitting on top of a 125-foot tall fire tower. So that's 125. This is our horizontal, not the ground. Okay. So the angle of depression is going to be right here, 19 degrees. How far is the fire from the base of the tower? Well, that's kind of terrible drawing, isn't it? This is 19. Always go from the horizontal, like I just said. That's the 19. See, going down from the horizontal, that's 19 degrees. And we're looking for X right here. So if that's confusing to you, just do this. Here's my angle of elevation or depression, 125 foot tall. How far is the fire from the base of the tower? Okay, really they wanted you to set it up like this, but you know what? It's okay. They're the same triangle here. I like it better this way because, well, it's just easier to remember to set it up this way. No worries about using the armpit angle here. It stinks. Anyway, opposite, adjacent, that's a tangent problem. Tan 19 is 125 over x. X equals 125 over tangent of 19 is 363.0. And that is in feet. You might be wondering why I put the 0.0. It is significant. If you know anything about significant digits, you know exactly what that means. If you don't, well, just think about it this way. If I know that it's exactly 363 inches, and I were, say, rounding, okay? So this number says that I rounded to the tenths place. This number, if I just left it all, if I didn't have that on there, I could say it's somewhere between 262 and 264. That's what 363 would mean. But this right here means it's somewhere between 363.1 and 362.9. It's more precise. So put the point O's, they matter. I'm not gonna take off points, but if it says round to the tenth place, round to the tenth place, even if it's a 0. Airplane altitude is that. Raft in the water at 28-degree angle of depression. So who cares? Draw it like this if you want. That's 28. That's 8,900 feet. Horizontal distance, x. These are all the same. I'm not even gonna do this one. Just do it yourself. Max is sitting in the baseball stadium. He catches a foul ball and decides to throw it back to the player standing on first base. So set it up like this and realize that this is our angle of elevation / depression. And it says the horizontal distance is 61 and the ball travels 76 feet. Did he throw it straight down? No. He threw it at an angle. Depression. So set it up. Adjacent, hypotenuse, that's going to be cosine inverse 61 over 76. You can type that in yourself. All right. think that's it for today. Well, for this lesson. Moving on.